Good morning guys, we are here, we're up in sunny Sheffield today. We are at Cobra Sport. We're going to see what goes on behind the scenes, see how your exhaust is made. We're going to chat to some of the guys and we're going to take you with us.
When we get a car in, what we do is we mock a system up to follow the tunnel underneath the car. This is from scrap bends. This is so we can make sure that we're maximising the sound performance, because with exhaust, with the things with exhaust is you've got two different types of waves that's travelling through an exhaust system. So you've got sound waves and you've got exhaust fumes as well. So sound basically travels like light, so it travels in straight lines and it bounces, whereas exhaust fumes flows like water. So obviously you've got to try and maximise your sound and you've got to maximise your performance as well. So once we've got this, we've mocked it up to the car, we use this Roman arm scanner. It's a fancy piece of kit. This is hooked up to our software on this computer here. And what we do is we can go like so, start a new project, which is 2 1/4. So this is a light sensor. And basically how it works is you start off here, and what you can do is you can scan each individual bend and it will get it up like that. So if we start here, and as you can see on here, it starts to actually scan the parameters of your bend. So it's got all your radiuses, all your diameters, all that included, and it'll actually give you a full scale model. So if I get this end bit here, right, do you want to have a go? Do you want to have a go? Just literally put the forks through there and then that'll give you that angle and that radius there. Yeah, now up and then about here. And then we just go on there.
That's freaking nuts.
And then it starts to map out your bend. And that's how we get a bend on his mandrel bender, which you'll see later. So this basically just tells you all the rotation as well. So not every bend is straight. So if you look down that, it's just slightly off on the rotation, and that'll just tell you the exact coordinates that you can then input that into a bending machine. And that's all through computer pneumatical control or CNC machining. So once you've done that fully, you will get a full scan there of the actual bend. And that is our bends, and they're your coordinates for your CNC. And what you can do there is you can copy it, as you can see, through 2 different bends, and then you can map it. So sometimes if you want to do an improvement like this, for example, the blue one will be a previous bend, and then you can make the alterations using this software just through that.
That's mental.
Yeah, there's more into it than there's more into it than what you'd think. And this is a very crucial piece of the research and development process. Yeah. So what we'd do is we'd mock something like this up on the car, scan it, bend it, try it in a jig. So we'd obviously jig that up, try the new bend in the jig, test fit it on the car, and then off you go. So this is the initial process of research and development. This is slightly different. This is as Indian Scout. So basically with this system, this is a new Indian system. It's a 2-into-1. Basically we've done that for flow of the system. And also it sounds silly, but the height of the system is actually quite low if you went 2-into-2. So what we've done is here, we've done a little cutout there. So in there, the exhaust will flow into 1. So you're going from a 2 to 1. And then it'll sit on the bike on the front here. So that will go like so. And another quite an intricate process is that we had to make our own cans. So we had to design a new can, which required a bracket. So this is the can that's going to sit on the side of the bike, and we had to mock up a bracket. So what we do is, to begin with, we mock up a bracket, just again out of scrap steel, get something somewhere like, and then what we do end up turning it into is the bracket on the thing. So that goes like so on the bike, and that will sit like there, well maybe even there, like that. And then how we do that is over here. I'll show you, taking them a tour. There's more, yeah, it's quite a long process and it's quite arduous, but when you see a project from start to finish, it's so rewarding. It's so rewarding.
So when you say that you change the bends based on how stuff flows around it.
Yes.
So like, would a tighter bend give a different sound?
Yes,
and that's how you're tuning the sound essentially.
Yeah. So basically, with sound, the more sort of kinks or bends, like for example, if you had a tight bend like this and you had multiple tight bends, like I say, the sound waves are travelling in straight lines, so they just bounce and bounce and bounce, and that will take a lot of the sound out. So you want it to flow nicely. However, you don't want it straight through. It's great power, but obviously it's going to be too loud. And with the noise regulations and everything coming in, you've got to be smart about it. But yeah, that's the big thing to remember, and a lot of it as well is the tolerances of the car. So your actual sort of from the design aspect, you are limited to what you're playing with the car sort of thing.
Especially with when you're switching from a stock to a 3-inch.
Exactly, this is what I mean. Exactly, especially when you're going up bore. I mean, sometimes like up ½ inch to an inch. You know what I mean? And it's all of a sudden you've got 15mm tolerance. You're going down to 5mm tolerance. You haven't got that much freedom, but that's the kind of thing we do like to do. Yeah. And with the bracket that I did show you, this is the finished article of that bracket.
Nice.
And we do that using SolidWorks. So this is our 3D model. I'll let you get that in.
And then that's just laser cut out.
And that's just laser cut out. So we send that drawing to the machine shop and they will get that done for us. So from that piece of steel that I've just showed you there, they will give it there and this will create this. And that's probably like a good month's worth of work there. And then for your exhaust today, you can also model the exhaust that you desire. There you go, you've got your Volkswagen downpipe there. And a lot of that as well is done on the roam around scanner that I've just showed you as well. So you can get all your coordinates and you can input it on here, and you can do it from a drawing if you wanted to, or you can do it from the bends. Now with this one it's a little bit different because you've got your flex there, and obviously with the flex it's a bit more difficult to get in the exact bend. And if you look at there, you've got tolerances on your the size of your vise in the mandrel bender. So for this it's made out of singular bends like these here, and what that basically creates is you can then work off a drawing rather than the actual coordinates. So there's two different processes that we can use there, but this is the kind of thing that would go through the research and development centre here. Once you've got this data, you've got your pneumatical control data, that's when it goes down to there for mass production.
That's awesome.
Yeah. We take pride in what we do, you know. This is we like to do stuff the right way, and we'd rather have something longer in for research and development to get stuff right.
So how does the procedure work? So you get your car in, it's got a standard exhaust.
Yeah.
Step by step.
Basically, with a new car, what we do is we'd basically before it comes in, we'd be doing the research on what the market wants and what's best for the car as well. So we're looking at performance and sound again. We'd also look at key things. So, for example, valves. Valves is a big one. How are we going to get around a valve? So for a valve, you might have to do something with a rear box, you might have to do something different with your system. We can't go into too much detail on what we do with that, but they're the kind of obstacles that we do. We then get a plan of what we're going to do. So when the car comes in, we start making the official mock-up there. We get the mock-up, we make the jig, scan it, make the bend, and then from there we can look at variants as well. So for sometimes we might do all that process and it might be too loud, and then from that you can then literally say, oh, we've got enough room here, here and here for a resi. We might need to put a sports cat in, we might need to put a flex in. What we do is we do road tests, and that engine is going on the dyno next week as well. So we do dyno as well. We just get it on dyno, check the power. So, and then from there we just get all the marketing done and it's off down for production. It's quite a lengthy process. It's a lengthy process, but when you see the project from start to finish, it's one of the most satisfying things.
When it's all done so nicely with all the little Cobra
and you like
super satisfying.
Yeah, big time. Especially when there's like little intricate bits like this. Like even this bracket, like I mean, it sounds daft, but there's a lot of work that goes into that. Do you know what I mean? Like, you can have a look if you want.
100%. A lot of people wouldn't probably appreciate how much work goes into stuff like this.
I mean, you know, like, because you've got it. There's so many different tolerances and variables involved, and particularly the R&D technician by hand can only do it so good. And then obviously from there, you've got to go and then you've got to tweak it on here, and then you're looking at your different planes and how it's going to sit. Where's that Cobra logo going to best sit? And then obviously you've got to incorporate the studs on the bikes. There's also little things, like I say, with the Indian where it'd make sense to do it as just two pipes, but the problem is with the two pipes is it's going to sit too low, and then you've got to think about packaging as well. It's like there's so many different variables that you've got to consider all the time. So it's not just a slap it together and get it sent out. It's a full engineering process, how we get to it, how we get our finished exhausts.
100%. So is that going to be a production exhaust?
Yes, that's going to be, yes. So the customer that we do the research and development on the car, they get their exhaust, and that's theirs for life, sort of thing. And then obviously then the jig will go down to our manufacturing centre, and then it'll get made and you can buy it on his website. So the sole purpose of research and development is for people just be able to buy something in Australia and fit our exhaust at home. And which is why with the 2-in-1, it's also easy for someone without any mechanical experience to be able to fit the exhaust to the car or bike, basically.
That's unreal. So would you take the stock exhaust off and sort of look at the bends on the stock exhaust?
Sometimes, yeah.
Almost.
So with that, we can scan an OE exhaust as well.
Okay.
So with the stock exhaust, sometimes we can literally jig a stock exhaust, scan it, and then produce it. I'm thinking there actually. Perfect example of a super downpipe. Jigged it up. I can't show you the jig too much, but
top secret. We'll blur that.
Yeah.
Properly held in position, isn't it?
Oh yeah.
Properly.
Because
but
you've
it's got to be like.
There's a lot of heat that goes into that, mate.
Yeah.
A lot of heat that goes into that, and with heat, everything just moves everywhere.
Yeah. This is all like TIG welded.
Oh, everything's TIG welded. Everything's from T304 stainless steel. There's flexers, there's stainless, there's cats. They're all locally sourced as much as we can. So we've got us made in Sheffield badge as much as possible.
Because they should all last forever, really. T304. Shouldn't
Yeah, T304. It's massively corrosion resistant. So basically, it's basically got around like an 11% mix of chrome in the steel. So with that, it creates a passivation layer. So basically, every time you cut into stainless steel, it creates a layer of chrome, and that stops all corrosion, stops all water from oxidising it, which will be known as rust. So it won't rust, it shouldn't erode, and they should last a lifetime if you look after them. Obviously, unless you're tramming it and you crash it, then it's a different story, but yeah, all being well, it's a part for a lifetime, and that's why we take so much pride and detail into creating this product. Change the design ever so slightly, but we can also do that. So sometimes we take direct stock front pipes and make a completely new one. So there's different ways of doing it. With the front pipes, we're a little bit more tricky. So we do try and stick to stock as much as possible with those front pipes. But this is for the new Toyota Supra GR. It's a pretty cool design.
Yeah,
it'll be great for your flow, that as well. Yeah. Great for your flow.
So with the TIG welding,
yes.
I know a little bit about TIG welding.
Right, okay.
So I know you have to, you're going to be able to explain this.
Right, okay.
So I know you have to put some gas over it to
yes.
stop it like oxidising.
Right, okay. So basically, so with TIG welding, it's a little bit different to normal welding because, for example, you've got the traditional welding is MIG, MMA, and TIG. Now MMA is stick welding, and the stick welding is basically you have everything has an electrode, and the electrode on stick welding is a flux core. It's coated in a flux core, and it's just a steel rod basically, and it's an electrode, and that is literally just a stick weld out here, and you just burn it in, and that'll do it all for you. MIG welding, you've got your filler wire in with your electrode as well, and that's where you just pull the trigger and pull it across. However, with a TIG welder, you have to apply the wire yourself. So with us, we use as a foot pedal, and the reason why we use a foot pedal is you can then hold your torch like a gun. So basically, you can just dab your things in like that, and then that's your pedal, that's your trigger, basically your foot. And basically, we're using pure argon shielding gas. Now, what shielding gas does, it protects your weld from the influences of the atmosphere. So, like, there's nitrogen and oxygen are the big two. Any sort of cross contamination in your weld will cause it to be weaker. It can cause something called porosity, and that's where there's just holes in your weld, and obviously exhaust gas is going through there, it's going to leak. You get something called pitting, where acid forms in those pockets, and they'll drip out, and then it'll start to corrode it instantaneously and just ruin your weld. So that's what the shielding gas is used for, and for this it's just actually apply your own filler rod. So we tried to use bigger cups as well for better gas coverage. So this is a 16mm diameter cup rather than a traditional 12mm. This just means that you get your better gas coverage, so you get your better colour on your welds. That's what causes your colour.
Rainbow.
Nice rainbow colour. Yeah, that's what makes this exhaust really nice, really. So
that's wicked, because with TIG, you often see people doing it without gloves and stuff. So
you can do. I'd say not supposed to.
Watching some sketchy people.
Probably watching some sketchy people, but I think the thing is, it's all about control. So obviously, like I say, with the MMA welding and with the MIG welding, you've got your electrode and your wire all in one. So you haven't actually having to put any filler wire in to make your weld stronger. That'll just sort of do it for you. Like with a lot of stick welders can just do it one hand. Same with MIG welding as well. But with this, the trick is there's two ways to do it. You can either weave like that, you just leave your rod on and do that. That's not the strongest. What we like to do is something called dab welding, where it's basically you start your fuse. This is your fusion puddle, and that is actually what is joining the two parent metals together. And then with this, you're dabbing in to your puddle and moving across the joint. Now there's two ways to do that. You can either just dab it in like so, or what we like to do is we like to push it through as thumbs like that. So you're pushing it all the way forward, and that's your filler wire. And the beauty about TIG welding is that you have complete control over what this is doing. So like with MIG welding, that you set your wire speed, for example, and that's just going to come out at that constant speed all the time. Same with stick. The electrode is going to burn away at whatever power you've set it at. This, you've just got complete control, particularly with the pedal. So with the pedal here, you can turn that right up to the max amp, but then when you go to like the max amps, for example, that like when you hit the pedal to the floor, that'll be at like the max amp. But then it's just like a car, you just adjust your amps and you can adjust your wire at ponds. So it's just for me, it's the ultimate precision welding. Particularly for what we do, we can literally control as amps with 1 foot, and that's just varying all the time. So you can just literally do as you please, really. It just gives us the most control over as variables as possible, really. So I'd say it's one of the more difficult welding processes. 100%. But obviously I'd be biased. But
I did have a go once.
Did you?
I couldn't do it.
What did you do?
I was just messing about with some tips from our place, and I just couldn't do it.
No, it's
One
difficult.
of the lads that was there could do it, but it is difficult. It's like you have to sort of wait for it to melt and then sort of dip it in.
Yeah. And I think the thing for me as well with TIG welding, you can put your own spin on it. So like for example, I can pick this up and look and just say it's Mark's welding, because everyone's got their own sort of personal style, and it's actually quite artistic, I believe, anyways. And you can put your own style onto it, and like I can pick that up and say that's Mark's, and someone will probably pick mine up and say that's Will's. And that's the beauty about TIG welding, because it's quite a personal thing and everybody has a different style. And that's why we use it, because it's just maximum precision, and it's also really, really strong as well. And like I say, it's perfect for stainless steel. You get these lovely colours, and you can just control each bead, each bit of weld pull. You can just have complete control over it. We do take genuine pride in his exhausts. You know what I mean? We're not a backstreet guys that's just going to slap it together under a ramp. We take his time into making his products. We try and use as much locally sourced produce as we can, and we really put his effort into making his exhaust. Like all this process is before, if you ordered an exhaust for a car that's just been released and we haven't got a product yet, all this process has been made before someone can get it on the drive. And that's what people don't see. You know, people think it's just an exhaust off a shelf. It's not. There's all these little processes that go into making an exhaust, really. So,
I mean, it's super impressive.
This is the starting point. This is the starting point. It is impressive. It's a great place to work as well, to be honest. Really good place to work. It's so interesting.
Yeah.
And a good thing with us as well, every day is different as well. You've got so many cool things to work on, like, being able to say that you've worked on a Toyota Supra's pretty awesome, let's be honest. I like that Indian as well. That Indian's cool. I was never a bike person myself, and then I seen that Indian come in, and
it's all interesting.
It's nice, yeah.
You need something new every day to keep your mind running, don't you?
Exactly.
That's where the ideas come from.
Yeah, 100%. Yeah. And the beauty about it is as well, everyone here, it's got a great culture here where everyone's opinion matters. It doesn't matter where you are in the company, and because of that, everyone's got a culture of, this is our company, and we all bounce these ideas off each other. Because a lot of us as well, we've seen it at every stage as well. And it's great stuff, really interesting.
That's what you need. You need everyone involved.
Yeah.
You can certainly feel it just from chatting to everyone that was spoke to today. You certainly feel it. And you can feel it just within the Cobra brand, just like coming forward with the level and the new products and the quality of the new products that keep coming out from.
Yeah, and this is the thing as well, like they massively invest in their own staff, and when opportunities arise here, they'd rather invest internally than invest externally. So for me, I was an apprentice here 3 years ago. They invested in me massively, and I'm very grateful for it. I went through the production system, just bench welding, and then I've been on research and development for 2 years, and now I'm junior project engineer. And that's me coming from just a standard level 2 apprenticeship. I've done some manufacturing. I did a P-rail project last year, and at all these different points, they could quite easily have said, we're going to invest in someone externally. That cost a bit more, but he's got more experience. But they'd sooner invest in his own talent. We've got Sam there on the custom ramp. He's been an apprentice with me as well for the past 3 years, and they invest in his own.
So you're an apprentice?
I'm still, yeah, I'm an apprentice. Mate. Yeah, I finished my apprenticeship in July, and then I go on to a degree apprenticeship at the AMRC Training Centre in September, which is all funded by a company. So that just goes to show you what kind of company they are. And the good thing as well is, you know, we're getting hit with so many different regulations with exhaust now, you know, with front pipes and CATs and GPFs, but they're trying to look at manufacturing. So last year we made 844 handrails for the Co-op Arena in Manchester, and I'll show you a new manufacturing project down there in a bit. And we're just trying to expand as depth of knowledge and expand as skills and expand as brand, so that in the future we're still going to be relevant.
There's definitely big change coming,
yes,
in terms of noise limits,
yes, CATs,
emissions, GPS,
exactly,
big
everything.
Changes coming.
Massive changes, and for us, and the biggest thing is 2030 supposed to stop the production of petrol and diesel cars. Now for us, that's a massive issue, but that's where the manufacturing can come in. But we've still got a lot left to give on the exhaust. We've got a lot left to give, and like I say, here we've got some really skilled and talented guys. We've got a lot of projects coming up, and it's really exciting times, mate. We're a company on the growth, and everybody here, they all see it as, you know, like a job for life, and everybody's just really putting into the company, and it's a fantastic environment, to be honest. It really is.
It's nice to feel it. The whole facility here is
it's pretty cool.
Impressive.
It's brand new. I mean, it's only a year old, this facility. We're just outgrown, like I say, with manufacturing projects and things like that. We did those P-rails last year for Co-op Arena, and we were just running out of space, and then built this purpose-built development centre. So like I say, we've literally got a building purpose-built just for producing the exhaust, just doing all the research and all the development, and that's what it is, a research development hub, and it's custom fitting hub, and we're expanding every day with bikes as well. Like, I'm sure that Indian's going to do very well. We've got a lot of interest in that.
Hopefully not going to be any electric bikes by
electric bikes, yeah, exactly, definitely not. I think that's one thing that they'd always struggle to do, to be honest. Electric bikes.
You can't get rid of all the engines.
You can't get rid of all engines.
Get rid of all of them.
And as well, at some point, these are all going to be classics. You know, these are always going to be classics at some point, and everyone's going to want an exhaust system on the classic car. So
there's always going to be some kicking about, but definitely something that at least has been on my mind as well. It's like, where is the industry going? There's going to be no intercoolers, no intakes, no exhausts. It's like, where's it going?
Exactly.
It's definitely something that everybody needs.
We're in a bit of a limbo, I think, at the minute. I think that's the best way to describe it. We don't know if we don't know where we're going at the minute. You know, there's a few shoddy things, you know, and we just have to see where we go. But we're confident in our own abilities of where we can go. And like, we just did a hybrid car last year for BMW 330e, and that was a really cool project. Quite painful at times because there's a massive battery pack at bike and trying to work around that.
Even less room.
Even less room. Even less room. That's correct.